Greetings everyone. We will continue our discussion on problem solving using C. In the previous sessions, you should have learned about the fundamentals of programming in C. In this session, we will be going for more advanced topics regarding your C language. So in this session, first we will be looking about the syllabus part, which we will be covering as a part of this complete arrays. Then we will be looking about the introduction to arrays. Later we will be looking how we will be having arrays in C language. Then we will be looking about the array applications, and we will be looking at all these topics one by one in this session. So coming to the syllabus part, your unit 3 regarding your programming in C will be about 3 parts. That is, will be about, first we will be looking about arrays, then we will be learning about strings. Later we will be looking about other related topics related to arrays. So first, as a part of arrays, we will be learning initially the introduction part about the concepts in arrays, how we are going to have arrays in C language, then what are the array applications. Then we will be looking about one-dimensional arrays and two-dimensional arrays and multi-dimensional arrays. Then we will be looking about some of the programming examples while learning all these topics like calculating averages. Okay, apart from that arrays topic, we will be having strings, which will be a subsidiary of your arrays. So as a part of strings, we will be learning string concepts, then string input output functions, then an array of strings. Then we will be learning about how to manipulate strings by using your string manipulation functions. Then we will be having conversion function, that is how to convert your string to data and data to string. And we will be having one programming example regarding one Morse code. Okay, so we will be learning all these topics as part of strings. Apart from these two parts, we are having the third part regarding your enumerated types, structures and unions. So initially we will be learning about type def, how to declare your type definitions. Then we will be looking about enumerated types, then structures and unions and other programming applications. So as a part of this unit, we will be having these 3 parts, that is arrays. If you understand arrays, it will be much easier for you to understand the strings concept. So apart from that one, you will be learning about your enumerated types, structures and unions. So we will be looking at all these topics as a part of this unit. So we will be going about that one by one. So first we will be looking about what is an array. So far we have seen all the fundamental data types like your int, float, char, double. So you should have learned about the various data types, that is, you will be having your fundamental data types and derived data types. One such derived data type is your array. So first we will be looking about what is an array. An array is collection of elements, and they are of the same type, that are referred to by a common name, and they will be stored in a continuous memory locations. So first we will be looking at the definition part, then I will be giving you why you need arrays in C language. So as you can see, it will be a collection of elements. So far you have been using only the individual elements, like whenever you are declaring a particular variable A, so we will be declaring individual elements like float, salary, okay, char, ch, double, f. Like this we will be declaring all the individual elements. These individual elements will be able to store only a single value. But when you go for a large number of values, you will not be able to support by using individual elements. That is why we need a collection of elements. Okay, your array is one such collection of elements where you will be dealing with large number of values of the same data type or same type. Okay, you will be having all these collection of elements, and you are going to deal them in only one data type. That is, either you will be dealing all the collection of elements as integers, or all the collection of elements as floating point values, or all the collection of elements as characters, or all the collection of elements as double values. So each and everything will be a same data type elements, whatever you are having that collection, and they are referred by a single name. So if I want 5 different values in my program, I have to declare 5 different variables like A1, A2, A3, like this. I have to declare 5 different variables. Okay, so but if I want to have 100 values, I cannot declare 100 different variables. So it will not be feasible for you to write a program with 100 different variables. So in order to overcome that, we have arrays where you will be referring all the collection of elements with a single name. That is, if I am having 100 elements, all will be under a single name A. Okay, so As you can see, an array is a collection of elements, that is, we will be dealing with large number of values, and they are of going to be same data type, either an integer, either a float value, or a character value, or a double values. All the values or all the collection of values will be only a single data type, and they will be referred by a common name. That is, you are going to refer all the 100 elements by using only a single name. Then they are stored in a continuous memory locations. All the 100 elements in your memory will be present side by side. They will be present one after the other in a memory location. So I will be showing how these particular elements will be present in your memory location, but have the grasp of what is the complete definition of an array. An array will be a collection of elements which you are going to have of the same data type, which will be referred under a single name, and they will be stored in a continuous memory locations. So this complete part you are going to implement in your C language. Compared to your basic data type like your int, float and char, this is an aggregate or derived data type. So whatever you are having, that is your int, float, char, all these data types, will be calling them as the fundamental data types or your basic data types. Okay, this particular thing, that is array, is a derived data type, that is we are going to derive those things from this fundamental data type. Okay, when I create an integer array, I am going to derive that particular integer array from your integer fundamental data type. So these are simple elements and you are going to store only a single value, but when you go for your array, you are going to store aggregate of values or large number of values. That is about your basic definition of an array. So next, why you need array in your C language or any language? Why you need arrays actually? Suppose you are having a list of 100 elements or 1000 students in your list, and you have to store these 1000 student marks, okay, of integer data type. If using basic data type, that is if you are using an integer data type, if you are having only the basic data type and if you doesn't have the arrays, what you are going to do? You have to declare something like this in the following manner. That is, if I want your 1000 elements in the program, what I have to do? I have to declare S1, S2 like this, S999. Okay, I have to declare 1000 variables to store the 1000 marks of your particular class students. So if I am going for still larger values, that is large number of values, at that time your fundamental data type or your basic data types will not be feasible for you to write the program. Okay, so this is why you need arrays. Whenever you want to implement large number of values in your program, you are going for your arrays. So by using an array, we must declare the same thing by this statement. So if I want 1000 elements in my array, I am going to declare in this manner. That is, I am going to try to store integer values. That is why I specify int. Okay, all these 1000 elements what you have specified, this will be the size, that is these many number of elements I want in my program. So these many number size I will specify. If I specify 1000, I am telling that I am going to store 1000 values or 1000 student marks in my program. So this is the single name what you are using. Okay, this will be the array name. Okay, array name. This is the single name under which all the 1000 values are stored. So this is how you will be having the declaration of an array. That is, you are going to tell your compiler that this is an array of 1000 elements. That is, I am trying to store 1000 elements in my program. So that is how you will be having arrays. If you see the declaration of 1000 elements by using basic data type, and if you see the declaration of 1000 elements by using a single statement like this, you can understand that this will be a better solution for you. So if you go for a 1000 element like this, S1, S2 like this, so on, S999, S1000. So this is how you have to declare by using basic data type. But if you use an array, you can have a single statement and tell that that is the student marks you are going to store, and you are going to store integer values, and you are going to store 1000 different values in the program. So this will reserve 1000 continuous memory locations for storing the student marks. So when I say an array, as I told you in the definition itself, all the student marks will be stored in a continuous memory locations. All the 1000 memory locations will be present side by side, and all the student marks whatever you are going to store, they can be stored in your memory locations side by side. So this is why you are going to have arrays in C language. And the same thing if you see the graphical terms, that is how you'll be having your arrays. So as a how then the declaration, you have declared something like this: int student marks of 1000. So this is the declaration you have done. So I am going to tell that this is the 1000 marks you are going to store, and this is the student, this is the array name, and you are going to store integer values. So the memory representation will be in this manner, that is the elements will be starting from one memory location. It need not be from 0, it might be from any value. So we are going to start at one memory location, and all the continuous memory locations will be present to store the 1000 elements. That is, all the 1000 memory locations will be side by side, and inside those values, the values will be all integers, and each position, that is, the first position will be represented by 0, the second position will be represented by 1, so on up till 999. So this particular position will be calling it as the index or subscript. Okay, for each and every array you will be having this index or subscript. So the index starts from 0, not 1, it will start from 0 to n-1. So for this array, since you are having 1000 elements, your index or subscript will start from 0 to 999. So your first element will be created like this: student marks of 0. The second element can be having the name student marks of 1. Like this, we will be having student marks of 999. So those many elements are created by the declaration, and you will be having the visual representation in this manner. So this is the memory, and these are the values, and this is how you will be having the complete array. Okay, all the values whatever you are going to store are integers here, and so the whatever the array you are having, it will have simplified our declaration of those variables. Okay, whenever you want to implement large number of values in my program, so if you are using the fundamental data types, you have to write large number of code. That is, you have to declare large number of variables. But this arrays have simplified your declaration of those variables into a single statement, and we can use the index or subscript to identify each element or the location in your memory. Okay, you can use the index of your array to identify each and every element, that is from 0 to 999. I can identify each and every element separately. That is, if I use student marks of 10, okay, this refers to the 11th element in your complete array. Okay, so this is how you will be having your arrays and their representation. So this is the visual representation of your array. So where you will be having your elements. So elements are present from these will be your integer values, and each and every element will be having a memory location. So since I am considering it as an integer, as you know, integer will be having 4 bytes. So each and every integer will be storing 4 bytes. Here we are having the first element at 1100 memory location. So the second element will be present at 11.4, third element at 11.8. So like this we will be having the continuous memory locations for each and every integer. Okay, next the subscripts will start from 0, or the index starts from 0 to your n-1, that is 0, 1, 2, 3 until n-1. So we will be having the first address, that is the first address of your array, we will be calling it as the base address, and the number of elements, that is each and every memory location we are having 4 bytes. So that is the integer space, we will be calling it as the width of your particular array. So this is a complete representation of your array, and the first subscript will be calling it as the lower bound. All these things will be useful for you while writing your programs. So all you have to remember is you will be having your memory addresses, and you will be having your values present in the each and every memory location side by side, and the subscripts will start from 0 to n-1. Okay. So in C language we will be having various types of arrays based upon the number of subscripts or indices you are having. We will be having one-dimensional arrays, two-dimensional arrays, and multi-dimensional arrays. In a one-dimensional array we will be having one subscript. In two-dimensional array we will be having 2 subscripts, and multi-dimensional array more than 1 or more than 2 subscripts we will be having. We will be looking about all these arrays one by one. First we'll look about the one-dimensional arrays. So the number of subscripts or indices determine the dimensions of your array. So as I told you, if you are having one subscript, we will be calling it as a one-dimensional array. Two subscripts mean two-dimensional array. And an array with one subscript or index is known as one dimension, and so on. Okay. Next, how to declare or how to conceptually visualize all these things. That is how your one-dimensional array will be present, how your two-dimensional array will be present. Initially, we'll be looking about the one-dimensional array. So conceptually, you can think one-dimensional array as a row where the elements are stored one after the other. So all the previous examples you have seen are one-dimensional arrays where you will be having your array and you will be having subscripts from 0 to your n-1, and it can contain values, any integer values or any values, and they will be stored in a continuous memory locations. All these things we have learned about so far will be about one-dimensional arrays. In the further sessions we will be looking about how two-dimensional arrays will be present. Then coming to the declaration of arrays, how you are going to declare your arrays. So like any other variables, an array has to be declared so that the compiler will know what kind of array you are using and how many elements you are going to store in that array. So you have to declare your array to tell the compiler what is the type of array you are creating and how many elements you are going to store in that particular array. So an array declaration will be in this manner, that is you have to have a data type, you have to specify the data type, space, your name of the array, what is the name of the array you are giving to give, then you have to specify the size. Okay, so this is the complete syntax of your declaration of an array. So a declaration is in this manner. Int, you are going to tell that I am going to store integers in my array, and max is the name of the array, and 30 means I am going to store at the max 30 elements in my completer. Okay. Similarly, you can have other declarations like float, salary, 30. Means I am going to tell that I am going to store 30 different salaries in my array. Or you can have char ch 20. Okay, my ch array is going to store 20 different characters in my array. So that is how you will be having the declaration. So in the declaration, this will tell the data type. Data type means what type of values you are going to store, and the name, the single name with which you identify the complete array, and the size, that is the maximum number of elements you are going to store in that array. Okay, this is the declaration. Before using any array types, you have to declare this array. Once after declaring how to access the elements of your array, that is you have declared some set of elements, that is you have declared like this, int max of 30. Okay, what is the meaning? Let's take some smaller value, int max of 5. That is I have created 5 different, I have created an array with 5 elements. So the indices for those elements will be 0 to 4. Now we have created 5 different elements in the particular array. So the first element will be denoted by max of 0. The second element will be denoted by max of 1, and the last element we can be denoted by max of 4. Max of 4. So in order to access, that is accessing means either I want to store some value into this particular position, or I want to read the particular value present in the position. When I declare your array, all those particular values will be present as garbage values. Okay, so the particular values, whatever whether you want to print those values or change those values, you have to be able to access the individual elements. So once after declaring, individual elements in the array can be referred to by using your subscript. Okay, so the subscripts are from 0 to n-1, the number in the brackets following by your array name. So I can use this particular syntax, that is I have to specify the array name. After that, in the brackets I have to specify the subscript, the particular element which I want to access. That is, if I want to access the third element, I am going to specify max of 2. If I want to access the fourth element, I have to specify max of 3. Like this, I have to specify the subscript and the array name to access the individual elements of your array. That is, if I want to access the first element, marks of 0, second element, marks of 1. So I have to use this particular syntax. Remember, this is the declaration and this is the accessing. Both are separate. Okay. So your declaration means you have to, if I write like this, it specifies that I have declared a particular array with 2 elements. If I write separately marks of 2, this means I am trying to access the third element in my array. Okay, I am trying to access the third element in my array. Both the statements are different. This is a declaration statement, this is the accessing statement. So once you can access the elements individually, that is, I can access marks of 0, marks of 1, marks of 2, all those elements individually. So you can access them individually or you can access them at a group by using your for loop. So how to enter the data into the array? So you can enter the data into the array by using your for loop, or you can enter the data by using individual assignment statements. So if you are declaring an array, I am telling that I am declaring 5 different elements. So you can access or enter the values into the individual elements separately, like a of 0 is equal to 10. Okay, you can access the individual elements separately like this. Now you have created one array with 5 elements and you have entered data into those elements separately like this. That is, now 10 value will be present here, 20 here, 40, 60, 70. That is 0, 1, 2, 3 and 4. Okay, so these are the elements, these are the subscripts for those elements, and we are storing those elements individually into the values. Okay, so that is how you can perform, that is, you can assign elements individually in this manner. Or you can assign at a time by using for loop. That is, your for loop, as you know, it will start from, you can start from the 0 element and go until the n-1 element. So that is why I will be using for I is equal to 0. In this example, I is less than or equals to 4 and I plus plus. That is, you have to increment your for loop from 0 to n-1. Inside that, I can use the scanf statement to get the individual marks. That is, if I write address of marks of I, okay, when my I value is 0, I am trying to access A of 0. When I value is 1, I am trying to access marks of 1. When I value is n-1, I am trying to access marks of n-1. So I can start from 0 to n-1 and I can group this same thing into one for loop. This is how you can perform entering the data into your array by using your for loop, or you can enter the data into the array by using the individual assignment statements. Okay, this is how you can enter the data into an array. Or there is another thing with which you can give the values into the array during the declaration itself. That is, while declaring yourself, you can give values by initializing your array. That is, you can have a declaration like this in num of 6. Okay, in the previous statements just you have declared, but you haven't given any values. So when I declare this thing, just they will be present there and you will be having garbage values in that. But if you can initialize like this, you can do. That is, while declaration itself, you have to give assignment statement, then inside the flower basis you have to give the set of values. That is 2, 4, 12, 5, 45 and 5 like this. You can do the initialization of this array in this manner also. So if you give some values, it will take the remaining values as zeros. That is, if I give int num of 4 and if I give only 2 values, 2, 0, okay, it will take 2, 0, 0, 0. It will take the remaining values as 0. So you have to specify some values to initialize into your array. So you can do the initialization in this manner also. So you can do, or you can give data into your arrays in three different ways. One is while declaration, you can initialize like this. Okay, so while initializing, you can skip your size also. There is no size. If you see properly, there is no size in this statement. So while declaration, if you want to omit the size, you can omit. It will directly take how many values you are taking. So if here you have taken 6 values, so it will take the size as 6 automatically. The compiler will understand that this particular array is going to have 6 elements, and it will initialize those 6 elements and the size to 6 automatically. Okay, this is how you can initialize. The second way is you can initialize, or you can give values individually by using individual statements. Okay, you can give values by using the individual statements, or you can give values by using your for loop. So these are the three methods with which you can enter data into your array. And the last part is how to read the data from your array. That is, you have entered the data into the array, and how you can read the data from your array. So you can read the data from your array by using your for loop, that is same by using the subscript, that is I have to start from your for loop from 0 to n minus 1. Okay, and when your I value is 0, the particular I value will be printed, that is A of I. So if you see this example, we have two examples here. One is to sum your particular values in your marks. We are going to sum all the marks in your complete marks array. So when your marks value is 0, it will take marks of 0. When your I value is 1, it will take marks of 1. Like this, when your I value is equals to 29, it will take marks of 29. So based upon your array, I value will be changing, and you can access or read all the elements in your array. Okay, so you have created your array. That is, you have created your array like this. When I have declared something like this in A of 5, you have created your array in this manner. So you have initialized or given values by using your for loop. Now you can print those values by using the same for loop. Like if I will write for I is equal to 0, I less than or equals to 4, I plus plus, printf percentage %d, okay, A of I. So when your I value is 0, A of 0 will be printed. A of 0 means 10 value will be printed. When your I value is 1, A of 1 will be printed, that is 20 value will be printed. Like this, you can access all the elements in your array from 0 to n minus 1 index. So these are the three parts you have to understand why using arrays. That is, you should be able to declare your arrays, and then you should be able to give data into those arrays, and third, you should be able to read data from those arrays or print those values in the array. And as you know, so in this session you have learned about all these basic concepts about arrays. That is, an array is a collection of similar data type elements, and an array is also known as a subscript variable with subscript from 0 to n minus 1 or size minus 1. So before using an array, you should be able to declare the particular array with the type you are going to use and the size with which you are going to declare your array. And however big your array may be, all the elements will be stored in your continuous memory locations. In the next session, we will be looking about programs regarding this particular array and also two-dimensional arrays. Thank you.